But I'm going to move forward and talk about how we use these oxidation states to do chemistry. All right? So here's a reaction. Sodium metal plus chlorine gas makes sodium chloride. I would love to do this reaction for you. This is a reaction we do in the lecture hall, and it's super awesome. This is quite a violent and explosive reaction. So you should look this up on the YouTubes. I don't have a little video ready for you, but look up sodium metal and chlorine gas. It's a really violent reaction. Okay? So if I were to go through and do the oxidation state of each atom in this reaction, we know sodium is in its elemental form, so it's 0. Chlorine, Cl2 gas, that's its elemental form, so that's 0. And now NaCl, we know that sodium in sodium chloride is a cation with +1 charge, with 1 plus charge, rather, right? So meaning its oxidation state is +1. And we know chlorine in sodium chloride is 1 negative charge, so it has a 1 minus oxidation state. Okay? So now let's look at what happened to the sodium. So in going from sodium metal to sodium plus, its oxidation state increased by 1. And going from chlorine gas to chloride anion, its oxidation state decreased by -1. So what is happening with this thing? Okay? Well, we have this really famous mnemonic, right? Oil rig. Oxidation is a loss of an electron. Reduction is a gain of an electron. All right? So if we look at what happened to the chlorine, in order to go from 0 to -1, it would have had to gain an electron. I'm going to say plus E minus, and I'll say E minus is our symbol for electron. Okay? Right? Because to have a decrease in its charge, it had to have 1 extra electron. That's how it became -1. Well, then what about sodium? Well, for sodium to go from 0 to +1, it's tempting to say, well, it had a proton added to it, but it did not. That would be a nuclear reaction if we forced sodium to take on a new proton. And I'm not talking about an H+ acid proton. I'm talking about a proton in its nucleus. That would be a nuclear reaction. We don't do those. It takes a very extraordinary set of conditions to add or take away things from a nuclei. So when you go from 0 to +1, that's because it lost an electron. So I'm going to say -1 electron, and that's what makes it +1. So now we note that if oxidation is loss of electron, then sodium has been oxidized. Okay, sodium lost an electron, so it has been oxidized. Reduction is gain of an electron. So we can see chlorine gained an electron, so it is reduced. Okay, and now what we have to think of is, I like to call this, making action verbs out of these. Okay, so if sodium is oxidized, who did the oxidation? Well, chlorine did, right? Sodium is not going to auto-oxidize. It's not going to oxidize by itself. Something has to oxidize it, and that's the chlorine. Okay? On the other hand, chlorine is reduced. It's not going to get reduced by itself, so sodium had to do the reducing. So when we identify which species is oxidized, we note that the other one had to be the oxidizing agent. When we note that the other species is reduced, we note that then the opposite one had to be the reducing agent. So think about that in terms of like an action verb. If this thing is oxidized, who did the oxidation, right? And that's why we call these redox or oxidation reduction, because where there's an oxidation, there's always a reduction, and where there's a reduction, there's always an oxidation. Okay? Another easy way to remember, so this is oil rig. Another easy way to remember for at least the reduction, which one is reduced, look what happens to the oxidation state of chlorine. It goes from 0 to -1. It was reduced in number. That's precisely why we use that word, reduced. Okay? So lots of ways to get around this. Whatever is the easiest way for you to remember oil rig. There's also another acronym, Leo says GER. Leo says GER. I don't know this one very well. So what is it? I guess loss of electrons is oxidation. Oh, now I get it. GER. Ha 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 ha. Loss of electrons is oxidation. Gain of electrons is reduction. Okay, so I like oil rig better, but if you like Leo says GER, that's okay too. Okay, so let's keep going. Okay, so here's an example. Identify the reducing agent and the oxidizing agent in the following balanced reaction. I'm just going to go for it. I'm going to walk you through how I do it. If you want to pause the video and give it a shot for yourself, then go for it. Okay. So first thing that I'm going to do, though, is add up the oxidation states. And I'm going to write the oxidation states in red here so I know what they are. Okay. So for example, I know each hydrogen has to be +1. I know each oxygen right here has to be 0 because this is O2 gas in its elemental form, right? Over here, I know now this is now a compound. This is oxygen in a compound. So each oxygen has to be -2 over here. And now in water, each oxygen is still -2 and each hydrogen has to be +1. So the only thing that I have left to figure out are the carbons. Okay. So over here in carbon dioxide, 2 times -2 is -4. So each carbon has to be +4. Okay, so I'm going to try to indicate which is which. Okay. And then now on methane, each hydrogen is +1. There's 4. 4 times +1 is +4. So that means each of these carbons have to be -4. And now what I want to do is identify each element or each atom that underwent a change. So carbon definitely changed, right? It went from -4 to +4. Okay? And let's see. So the hydrogens didn't change, so I'm not too worried about the hydrogens. And yes, aha. Each oxygen went from 0 to -2, both in water and in carbon dioxide. Okay, so what happened? Well, for carbon, to go from -4 to -8, let's think about what has to happen. So it's already negatively charged. So for it to go positive, it's not being reduced, right? The number's not getting smaller, the number's getting bigger. So that means that it had to be oxidized. And how I know it had to be oxidized is because to go from -4 to -8, that's like saying -8 electrons. Okay? So that's a loss of electrons. So I would say it's not just the carbon in methane, it's the entire methane. Methane is oxidized. I'm not going to identify what's the oxidizing agent yet. Let's just keep going through this thing. Okay? And so now oxygen went from 0 to -2 in both of these compounds, right? And then consider that we really have, 4 oxygen atoms in total, right? 2 times 2 is 4. Well, here's 2 of them, and then here's 2 of them. Okay, so we accounted for all of them. And so that means for this to happen, each oxygen had to gain 2 electrons to go from 0 to -2, and there was 4 of them in total, so that's actually an exchange of 8 electrons, which is kind of cool that we could account for all of that. If you didn't see the number 8, if you're not there yet, that's okay. The big important thing to note is it went from 0 to -2. It's being reduced, okay? So O2 is reduced. And note, we always say this with respect to the reactants. We're talking about what's happening with the reactants. Okay, so if methane is oxidized and O2 is reduced, that means O2 is the oxidizing agent and methane is the reducing agent. And here's another really cool thing, some kind of common sense. It's not quite common sense yet, but we'll call it chemistry common sense, which means it's only common sense after you've been studying chemistry for kind of a long time. Oxygen is always the oxidizing agent. Makes sense, right? I should say 99.9% of the time, okay? So that's how you know you did this correctly. Don't just assume oxygen's gonna be the oxidizing agent. You know, walk through this and make sure you get it. But yes, in a chemical reaction where there is O2, 99.999% of the time, oxygen is the oxidizing agent. That's called chemical intuition or chemical common sense, okay? Let's go back for a second. Check this out, right? Iron plus oxygen makes iron oxide. What do you want to bet in this reaction? Oxygen is the oxidizing agent. It is. Work it out for yourself. You should try this example out, right? Put together the oxidation states of iron and oxygen and so forth and prove to yourself that oxygen is the oxidizing agent, okay? It doesn't have to be the only oxidizing agent in the world, but certainly in a chemical reaction with O2, you guessed it,